Assalamualaikum warahmatullahi wabarakatuh. We, Siti Nurul SYAFIQAH binti Muhammad Yusuf, SHAFIKAH binti ANUAR, and NURFARAH binti SALLEH are going to present our assignment 2. This assignment is basically about solving a problem based on selected topic manually using simplex method and also with the help of software which is known as Lindo. This assignment also includes sensitivity analysis based on Lindo output. We chose an advertisement problem to be solved. This question is about a business application media selection. The advertising alternative for a company include television, radio, and newspaper advertisements. The cost and estimates for audience coverage are given in table below. For cost per advertisement, television 2,000 Malaysia ringgit, newspaper 600 Malaysia ringgit, and radio 300 Malaysia ringgit. For audience per advertisement, television 100,000, newspaper 40,000, and radio 18,000. The local newspaper limits the number of weekly advertisements from a single company to 10. Moreover, in order to balance the advertising among the three types of media, not more than half of the total number of advertisements should occur on the radio, and at least 10% should occur on television. The weekly advertising budget is 18,200 Malaysia ringgit. How many advertisements should be run in each of the three types of media to maximize the total? Based on the equation, this is a maximization problem. The equation asks how many advertisements should be run for each media, which is television, newspaper, and radio. First step of solving this problem, we need to let the variable first. From the equation, let x1 be the advertisement should occur on the television. x2 advertisement should occur on the newspaper, and x3 advertisement should occur on the radio. Next, we need to set the objective function. Since we know the question involves cost, so it will not be taken as the coefficient for objective function. Instead, we took the number of audience per advertisement as the coefficient for objective function. So, the objective function is Z equal to 100,000 x1 plus 40,000 x2 plus 18,000 x3. Right after we set the objective function, we need to identify the constraint for this question. From the question, it is said to be 18,200 Malaysia ringgit is the weekly advertising budget. So, the weekly advertisement budget will not exceed 18,200 Malaysia ringgit, while the cost per advertisement for each media are 2,600 and 300 Malaysia ringgit respectively. So, the first constraint would be 2,000 x1 plus 600 x2 plus 300 x3 less than or equal to 18,200. Next, for constraint 2, the hint given is the local newspaper limits the number of weekly advertisements from a single company to 10, which means the number of advertisements for newspaper or x2 will not exceed 10. So, x2 is less than or equal to 10. For constraint 3, it is said to be not more than half of the total number of advertisements should occur on the radio. This means that x3 must be less than or equal to half of the summation of x1, x2, and x3. So, constraint 3 is x3 is less than or equal to 0.5 times x1 plus x2 plus x3. For the last constraint, the hint given is at least 10% of total number of advertisements should occur on television. This constraint involves x1. The sign for this constraint is greater than or equal to because at least 10%. That means it's either 10% or more. 10% also can be written as 0.1. So the constraint is x1 is greater than or equal to 0.1 times x1 plus x2 plus x3. Since objective function has been set and constraints have been identified, we can write this in LP form. From this LP form, we change it into a more manageable LP form in order to ease the calculation. Next, from a more manageable LP form, we change it into a standard form. This step includes addition of slack in order to change the sign of less than or equal to the sign of equal to. So now, we can set the initial tableau from the standard form. Since this question is a maximization problem, in each tableau we need to ensure that there is no non-positive coefficient in row Z to achieve an optimal tableau. We make a further calculation to get tableau 1. In tableau 1, there are still non-positive coefficients in row Z, so further calculation needed to get tableau 2. Same as tableau 1, there is still a non-positive coefficient at row Z. Hence, further calculation needed to get tableau 3. Once we get tableau 3, there is no non-positive coefficient at row Z. It can be concluded that this tableau is the optimal tableau. We can obtain Z value and also value for x1, x2 and x3 from this tableau. From the tableau, Z is equal to 1,052,000 while x1 is equal to 4, x2 is equal to 10 and x3 is equal to 14. Hence, the total number of audience is 1,052,000 people. Advertisements should be run on television, newspaper and radio are 4, 10 and 14 advertisements respectively.
Hey, hello, my name is SHAFIKAH and I will be the second presenter for this presentation. So together we will solve this question number 2. So question number 2 state that write a manual report on solving this linear programming problem step by step by using Microsoft Excel solver or Lindo. So basically, our group have choose to solve this LP problem using Lindo. So next. So this is the manual on solving LP using Lindo. So the first step is basically you have to open the Lindo software and then next enter the LP model as stated below in the Lindo, and then lastly click solve to solve the LP model. So click Lindo, okay, so basically we have this is what we call the command tab, and then you have to type in the LP model in here. So as our problem is a max, so type in max 100,000 x1 plus 40,000 x2 plus 18,000 x3, and then enter and type in ST, which is stand for subject to, and then enter again to type in your constraint. So the first constraint will be 20x1 plus 6x2 plus 3x3 less than equal to 182, and then enter again for the second constraint, which is x2 less than equal to 10, and then enter again for the third constraint. So the third constraint is negative x1 minus x2 plus x3 less than equal to 0, and then enter again for the last constraint, which is negative 9 x1 plus x2 plus x3 less than equal to 0, and then enter. So you have to type in n to end the command and then enter. So the third step is click solve and solve the LP problem. So if you want to do the analysis sensitivity, you click yes here. So at the back of the command, we have the output. Okay, now as you can see, this is the output from the Lindo software. So basically, the optimal solution was found at step 3 as stated here. So as we do it in manual, we can also get the optimal tableau, and it occurred at the third tableau. Next, we have the value of z, which is the value of the objective function, and then we can also gain the value for x1 and x2 and x3. x1 is 4, and then for x2 we have 10, and for x3 we have 40. So the maximum weekly audience is 1,052,000 audience, where the number of advertisement for television is 4, and the number of advertisement of newspaper is 10, and the number of advertisement for radio is 14.
Hello, I am SYAFIQAH ANUAR, and I'm going to present the third last question, which is discuss in details the sensitivity analysis by giving at least 2 examples for each cases. For this type of question, there are 2 cases. First case is when there are changes on right hand side, and second case is when there are changes in the objective function coefficients. To solve the equations, we have to refer the output from Lindo. This is question 1 from the first case. If the weekly advertising budget is changed to Rm 30,000, how many advertisements should be run in each of the 3 types of media to maximize the total? From this question, the key point is weekly advertising budget, which is from the first constraint. Okay, so from this question, we have to find the data 1. Okay, since we know the new D is 30,000, so from the formula, 30,000 minus the D axis, which is 18,200. So we get the 11,800 as the data 1. Then we check the range at the right hand side range at the Lindo output. So we know that D2 is still in the range for the second constraint. We proceed the calculation to get the new Z. By using the formula, we get the value from the Lindo output. We got Z from the objective function value and DP1 from the first row of the dual prices. Insert the value to the formula, and then we know that 1657391.28 as the new Z. Okay, this is question 2 from the first case. if the weekly advertising budget is decreased to Rm 10,000, how many advertisements should be run in each of the three types of media to maximize the total? Same like question 1, the key point will refer to the first constraint. Since the weekly advertising budget is decreased to Rm 10,000, so 10,000 minus D exists 18,200, and then we get negative 8,200 as the data 1. Then we check the range at the right hand side range at the window output. From the range, we know that the change in right hand side is not in the range. Thus, the current solution is invisible. Therefore, further calculation will be needed to find the new solution. Okay, this is third question from the first case. If local newspaper limits the number of weekly advertisement from a single company to 11, how many advertisements should be run in each of the three types of media to maximize the total? From the question, the key point is local newspaper limits the number of weekly advertisements from a single company, which is from the second constraint. So, to find the data, new D, which is 11, minus the exist D, which is 10, and we will get 1 as the data 2. So, then we check the range at the right hand side range at the window output. Okay, then we will check the range in the right hand side range. Since we know that data 2, which is 1, is still in the range, so we proceed the calculation to get the new Z. By using the formula, we get the value from the window output, Z from the objective function value, and dp2 from the second row of the dual prices section. Then insert the value to the formula, and then we will get Rm 1063826.087 as the new Z. Okay, now I will present the second cases, which is when there are changes in the objective function coefficients. This is question 1 from the second case. If the audience per advertisement for radio decreased by 2,000, how many advertisements should be run in each of the three types of media to maximize the total? From this question, we know that the key point is audience per advertisement for radio, which is referring to variable x3. To solve this question, firstly find the data C3. Since the audience decreased by 2,000, so new C3 is 16,000. So, from the formula, 16,000 minus 18,000, and we get negative 2,000 as data C3. Then, we check the range at the coefficient range at the window output. Look at the third row, and then we know that C3 is still in the range for variable x3. So, we proceed the calculation to get the new Z by referring to the window output. Given formula, we find the Z at the objective function value section and the x3 at the variable x3 value section. And then we insert the values, and we will get Rm 1024000 as the new Z. So, the current basis variable remain optimal with x1 is equal to 4, x2 equal to 10, x3 equal to 14 with a new value of z. Okay, now it's time to question 2 from the second case. If the audience per advertisement for newspaper decrease by 10,000, how many advertisements should be run in each of the 3 types of media to maximize the total? Okay, from this question, we have to know that the key point is audience per advertisement for newspaper, which referring to variable x2. Okay, so since the audience decreased by 10,000, so the new C2 will be 30,000. So to find the data C2, 30,000 minus 40,000, and we will get negative 10,000 as the data C2. Then check the range at the window output. Okay, now look at the second row at the objective coefficient range at the window output. From this, we know that data C2 is still in the range. Then proceed the calculation to get the new z by referring to the window output. By using the formula given, find the z at the objective function value and x2 at the variable x2 value. Insert the values and we will get 952000 as the new z. To conclude, the current basic variable remain optimal with x1 equal to 4, x2 equal to 10, x3 equal to 14 with a new value of z. Okay, this is the last question for the second case. If the audience per advertisement for television change to 150,000, how many advertisements should be run in each of the 3 types of media to maximize the total? So, from this question, we have to know that the key point is audience per advertisement for television, which is from the variable x1. Okay, since the audience had changed from 10,000 to 150,000, we get the data C1 equal to negative 50,000. Then, we check the range at the window output. Look at the first row at the objective coefficient range section, and from this, we know that C1 is out of the range. Thus, the current solution is infeasible. Therefore, further calculation will be needed to find the new solution.